Okay, lecture module 10. We left off yesterday right here on the system development lifecycle. So let's review. Essentially, really, there are 5 phases. As I mentioned yesterday, the textbook adds a system acquisition phase. But again, in nearly every other text you see, you'll see 5 phases. And recall, I provided the acronym, from Star Wars, PADME: planning, analysis, design, implementation, maintenance. And again, the textbook adds this acquisition, which traditionally is put in implementation. You're purchasing equipment in the implementation phase. We need to recall that in software systems design, we have an iterative cycle. So we iterate over the phases, going back to former phases, and then, of course, moving forward. We do this continually, in contrast to the waterfall method that is used in, say, traditional building. Again, the traditional building, I'm going to build a house. I get an architect to create the blueprints. The blueprints are passed off to the contractor, etc. Okay, with demarcations between the phases. So let's take a look at the system development life cycle. Begins with the planning, problem identification. And why does this occur? New threats, new competitors in the marketplace who may have come online with updated equipment, so they're more efficient than what your organization may have. Of course, new technologies, and again, these may lead to better efficiencies or better effectiveness too. Um, New laws, just reporting, accounting, things like that. Emails, collecting and maintaining emails for, say, 5 years. So there are a lot of changes, a lot of influences from the environment. If you look at, of course, what's taken place here in the last year, with the pandemic and the lockdowns, everyone being thrust into this online world. Okay, new threats, new environment. So each phase, by the way, will have deliverables, documentation. The documentation is as important as each one of these phases. The deliverables, or documentation from a phase, will serve as inputs into the next phase. So the deliverables, the documentation that occurs in the problem analysis phase, will be fed into the analysis phase. This is critically important. For one, we want to document everything, but also institutionally, we want to promote institutional learning and expertise. Should we make mistakes, because we will be back in this system development life cycle at some point, 3 years, 5 years, who knows, we don't want to make the same mistakes. If we did something well, we want to replicate it. So again, this institutional learning that takes place is important. Okay, so in the analysis, of course, we're taking a look what's out there in the environment that we can use. Again, recall the ACM code of ethics and professional conduct stipulates that we as professionals remain abreast. If we don't remain abreast, well, our competitors are. So when they go to do their systems development lifecycle, they're going to do it better. They're going to do it quicker. When we assess our options, again, we're going to constrain them into numbers. We're going to do a cost benefit analysis. And again, it's not restricted entirely to quantitative numbers. There are qualitative aspects. Recall what I presented yesterday, in that accounting is that communication mechanism for business. Of course, accounting is money. But even accounting has evolved to accommodate qualitative measures, balanced scorecards, because not everything, you can't put a number to everything. Enhanced customer service. Why do we want enhanced customer service? I didn't present this yesterday, because it comes from marketing, comes from, MBA type material. It was discovered, and it's been proven since, that it is more lucrative, okay, financially beneficial, to retain your customers than continually going out and seeking new customers. Your present customers, what they're talking about is a long-term value. If you can hold your present customers and keep them satisfied, it's going to be more financially beneficial to you than continually going out there and, spreading your nets and trying to get new customers. So that's when we talk about long-term value, LTV. And you will encounter this from time to time in your future studies. So we're performing all of this environmental scanning, all this analysis of specifications. How do we tabulate it, document it, and then contrast it? How do we make our choices in what's coming in the design phase? So we put everything into diagrams, tables, trees, and models, okay, which allows us to evaluate them. But we also, in our documentation and our deliverables from this phase, we include questionnaires, the interview questions, any other analysis that takes place. Again, we're trying to be complete with our analysis. Recall, information, complete, accurate, timely, and relevant. If I have the possibility to have a complete information set, it would behoove me to do that because then I can make a better decision. So again, we capture and record everything for our institutional learning and experience. So when we look at our tools, the models, the diagrams, things of this nature, first thing we need to recognize the entity relationship diagrams, the ERDs. And I'll let you know, this is actually the basis of database management systems design, ERDs and entities. And I'm going to speak about this and present this in much greater detail in 2 weeks when we cover database management systems. But at this juncture, again, just let's recognize what's at the core of every management information system, every computer information system. It's a database. So it makes sense to begin with the analysis from a database management design perspective. So we have entity relationship diagrams. Closely related to these ERDs is the notion of object-oriented design. It's a little different, but we'll present this as well. Decision tables and trees, and we'll look at these in the next slide. And lastly, class diagrams and use case diagrams, which are the basis used for object-oriented design. And you'll see several different terms associated with that. You'll see OOD for object-oriented design, or OOP, object-oriented programming. And most databases have evolved, we'll look at this again in the forthcoming chapter, to have some capability for objects. So if we take a look at the decision table, okay, we're just kind of tabulating. What can customers do? What should they be able to do? And we'll look at data flow diagrams. How does data flow through a system? And again, as I presented yesterday, this is that business process view rather than a functional view. Recall the functional view is that silo, right, approach. I have an accounting department. I have a human resources department, a sales department, those silos. But it's been proven to be more effective to look at business in terms of, say, inbound logistics and outbound logistics. How does data move through the company? Because again, this is the way that customers perceive your organization. So if we take a look at, again, the data flow diagram, we can see how, say, a customer would enact or interface with your system. Of course, they want to place an order. They'd have to give their user information, their name, their address, credit card, things like that. At which point, of course, if they place the order, then it's going to, supply, the order is going to be fulfilled and shipped. And we can trace this throughout the program. Recall another term I used yesterday, process mapping, okay? A data flow diagram will reveal the process mapping that I've done throughout the organization. Unified modeling language, UML, and use case diagrams. We're going to look at this in greater detail next week. Next week, we'll be covering programming. So we'll actually look at object-oriented design and alternatively, object-oriented programming. But just in advance of that, take a look at this. We are describing a customer. And essentially, this is an object. But I could also look at it, basically from an entity perspective as well. What is a customer? A customer will have attributes which we think of as static. Now, the customer can change their name and their phone number, things like that, but they're static. And their behaviors or alternatively known methods. So this will be the programming, the algorithmic. These are the interfaces. What can a customer do? They can change their telephone number. They can change their address, place an order, etc. So this is a UML diagram right here. Okay. So a UML diagram will have the attributes of the object and the methods, what it's permitted to do. The methods will be logic. Essentially, the attributes will be variables. So, and we can describe it pictorially here, but really this is complete, this UML here. The use case diagram, again, lists what a user in the system can do, but essentially that's the methods, the public methods. And I'll get into public versus private methods for those of you who are in programming logic just next week. Okay, so we've done the planning, the problem analysis, and then we're moving into the design phase, specifying what the new system will look like. And this will lead us into rapid application development, but also, as I mentioned yesterday, joint application development. Now, joint application development, where I engage all constituencies throughout an organization, will occur in the previous two phases. But recall, with the iterative model, I'm going to iterate. Okay, I'm going to go forward and backward across the phases. Joint application development, again, I need to solicit from the various populations within an organization what they need, what their concerns are, what they would like to see. And again, it just goes beyond just development of the system, but that also enhances the organizational culture. I mentioned this yesterday. If we can engage everyone within the company, they become our ally. We're going to see one of the major components, one of the major costs of system development is training. If I can get the organization on board and have allies throughout the organization, they will train each other. They will train new people when they come on board, rather than me hiring a trainer, stopping all work for a week and training people, where productivity, of course, is at a base level. So system development, the design, okay? So we're creating a model of the new system, and we're creating a data dictionary. Data dictionary describes all data in the system. This too comes from database management systems theory. Describing all data in the system, well, what are we doing? We're giving it context. Recall that memory hierarchy, right? Data, information, knowledge. And as we add context, we push it up in that hierarchy. And it's our goal to push it as high in that pyramid as we can. So the data dictionary is actually a first start in describing the data and pushing the data up to be at an information level. Okay, again, we're going to work with those data flow and class diagrams that we created back in that analysis phase. Another note on, I just described joint application development, engaging everyone within an organization, but rapid application development. I want to create mock-ups. I want to do something and get it in front of the people who are going to be using the system to get their feedback. Now, again, this plays into joint application development, but hopefully it gets them on board in helping me create a better or best system. Now, when we do this, of course, we're providing mostly interfaces, but at this very time, recall what I said about software engineering yesterday. A large component of software engineering is developing those application programmer interfaces. How does the software integrate, fit together, right? Because if you're calling a particular method, it has to have the right number and type of arguments. So we're going to see this. So a large component of rapid application development is also creating and specifying those APIs. And those APIs, we have to do so with a future perspective, because down the line, as we upgrade this system, we want to be sure that we can accommodate any unforeseen functionality that comes along. Okay. Within the design phase, again, we may have, depends on the organization. The organization may have the in-house expertise to specify everything, or with a smaller firm, especially if it's not an IT firm, it may not. which means we have to go outside the organization. Two different requests, request for proposal and a request for quotation. The first, request for proposal. The organization may not have the expertise to define what it needs to do, at which point it's going to go out and ask essentially the community, and the community of IT professionals, that is, how would you solve this problem? Okay, so that's a request for proposal. A little more specific, well, okay, I know what we're going to do, so now I need quotes to develop software, to purchase hardware. Now again, these requests, and hopefully I've communicated this, are very specific. The more specific you can be, the better. Okay. If you're not specific, you'll get requests, proposals that are kind of all over the place, quotes that are all over the place, quotes for equipment that may not meet your needs because you were not precise enough in your specification in the request for quotation. There's a significant amount of knowledge just to create good RFPs and RFQs. Now, coming in the other way, if you're submitting a proposal, a company has sent you an RFP and you're submitting a proposal, please make sure you abide by everything they ask for in the format they ask for. There's a reason we do what we do in the Linux labs. We're preparing you for what occurs out there, because any omission, any error will reflect poorly on you. I'll give an analogy. Hiring, as the department chair here for 19 years, so we're of course have searches for faculty, and I'd get back 200 to 500 resumes. I could throw half of them away because they would have spelling errors, because that does not reflect well on that candidate. If you can't send me an error-free resume, I have no confidence in your ability to teach in this curriculum. But the same thing applies in business with the RFPs and RFQs. If you have a mistake in your RFP or RFQ that you submit to a company hoping to get a job and they see it, why should I trust you? You can't even send me a mistake-free RFP or RFQ. So again, this discipline is precise. It's the nature of it, fact-based. But also, if we look at what's occurred, especially with the pandemic, everybody's been thrust online to where I can hire someone from almost anywhere in the world who's going to do it best. It's leveled the playing field, which is becoming more and more competitive. When it comes time for the organization to evaluate the bids, we'll create tables, we'll create metrics, rankings. If you can do this, I'll give you 3 points rather than 4 points or 4 points or 5 points. And you'll kind of create this ranking system, which hopefully will allow you to select the best way forward, proposal or quote, to meet your goals. Okay, so we've moved through the problem identification to the analysis to the design. Again, each one of these phases has deliverables to the next phase. And again, we iterate, so we can go back to analysis, we can go back to even problem identification and move forward into the design phase. When we get to the design, the output, of course, is going to be those prototypes, RFPs, RFQs, anything. And all documentation when we evaluated the bids. Down the line, we may find that we had an oversight, a shortcoming, okay, in our evaluation process. We want to record that. So again, 3 years down the line, when we have to go through this again, we actually incorporate what we missed. Document everything. Okay, again, acquisition really is part of the implementation phase. Listing it as a separate phase actually forces us to iterate and go back, because again, we don't want to purchase items before we need them. In the system implementation phase, it may take 6 or 12 months, even longer, to develop that system. I don't want to purchase something and just have it sit there for a year before I use it. One, it could be obsolete. Newer things could come out that would surpass it. But minimally, sitting there If I were to purchase it 6 months later or a year later, I could probably get it less expensively. So keep that in mind. We will have to decide on whether the make or buy decision. So does the organization have, say, in-house programmers, in-house database managers? Okay. But it's not only that, they may have the internal expertise, the institutional expertise, but they may not be able to release their employees to work on the new system because, of course, they're involved in their day-to-day operations. So again, there's a lot that goes into evaluating whether I purchase software off the shelf or do I develop it in-house, or combination. Do I purchase it off the shelf and then slightly modify it to meet my needs? Now, even this is rife with problems, of course, because the software over time, there will be updates, patches, right? So those programmers may actually have to adapt their customization as new patches and updates come out from that software vendor. Implementation. Implementation is where it really gets fun. Putting it all together, the hardware, the software, testing, testing, okay, as best as we can do. So test data should be realistic. Yep. Should probably do some penetration testing, edge cases, see if you can break the system. Conversion, implementation conversion. There are 4 paths an organization can take: direct, parallel, phased, and pilot. The worst path to take is the direct conversion, which unfortunately many organizations are forced to use. With the direct conversion, essentially, as an example, Sunday night at 12 o'clock, the old system is shut off, all the new software is loaded. Monday morning, the new system is put online. Fingers crossed. Hope it works as it's supposed to. So if it's the least, effective way to do it, why do organizations do it? They probably don't have money to purchase all new hardware. They have to reuse their old servers. Okay, so this happens to a lot of organizations. The best conversion process is the parallel conversion. I buy all new hardware. I load the new software onto the hardware. Monday morning comes, I turn it on. But should something go wrong, I have that old system there. I turn the new system off. I, re-energize that old system. Of course, with the direct conversion, you can't do that. There's no turning back. You've moved forward and installed the new software. Granted, yes, you could install the old software back, but then you're going to be down for a day or so, and that doesn't really project trust to your clients. Phased conversions work well, but are more complex. If I'm going to bring modules on one by one, well, of course, that module must work or interface with the old system, and it must also work with the new system. Okay. Down the road, once the entire system has been, converted, you still have those old linkages to those legacy systems, and you need to continually test those for vulnerabilities. Those may be security vulnerabilities. So phased conversions work well, but they're more complex in the design because they have to interface with both the old system and the new system. And then they require more management over time because you still have all those old linkages to that old system. And who knows if they may represent a security vulnerability. Pilot conversions. Pilot conversions work well for some types of organizations. The typical example is the bank with a small pilot office. It's very easy or conceivable to give those tellers at that small branch office the new product, the new interface. See how they like it. You haven't affected the rest of the organization, just that small pilot branch. And if it works well there, yes, deploy it throughout your other offices. So those are the 4 different types of system conversions. User training. User training is very expensive. Why? Because quite often you're going to take your workers and take them out of their work just to train them. It's essentially downtime. Your organization can come to a halt. Many organizations, some of you may have experienced this, just bypass this and just drop the new software on the workers. This is rife with problems because, again, do they know what they're doing? Are they going to be engaged in what they're doing? They're going to speak ill about what they're doing. They're going to leave your company. They're going to take their knowledge and go to a competitor. All of these things can happen. User training is very expensive. It's downtime. Are you paying trainers? And again, here's where if we had engaged, and quite often if we had been allowed to engage in joint application development, then hopefully the workers are on our side. They'll train each other. They'll train new people. They'll help each other, okay? Rather than just speaking ill about the new system. The maintenance phase is the most expensive phase for many reasons. One, it's the longest phase. When you can go through, the planning, analysis, design, implementation, maybe in a year, maybe 18 months, you may have that system running for 3, 5, 10 years. So obviously it's going to cost the most. Additionally, over time, you're going to have to upgrade certain components, accommodate new technologies, accommodate many unforeseen things that may cost you. You may have middleware throughout the system that requires continual programming. So you have, a staff of programmers who continually work on the system. And of course, you have system administrators, and their salaries, they're not cheap. So all of this goes into the system maintenance aspect. The final document is the completed project folder of all documentation from the previous folders, but it's not complete. We continually add to it throughout the maintenance phase. We may encounter something in year 3 or 4 that we overlooked when maybe we had the possibility of assessing it back in the analysis phase and possibly designing for it in the design phase. Again, the system is our goal. We want to develop and implement a functioning system that meets our needs, but that documentation is almost as important. We need to learn institutionally from what we just did. Okay, the remainder of the chapter is really just a classification of information systems. Um, I'm not going to speak much about it. It's presented in the textbook very straightforward manner. So, of course, everyone's reading it. I will add some things here and there that the textbook doesn't make clear. So the first is office and user productivity. We can think of large pools of administrative assistants, all using, Microsoft Word, Microsoft Excel, things of this nature. Maybe they're in a virtual desktop interface environment. So of course we need to design for that. If you look at, say, our college registrar's office, right? They're all working with our scheduling and registration software, user productivity. Okay, so you can imagine this in each industry. The airlines, their registration systems. So these would all fall into office and user productivity. Communication systems, of course, something we all use, something really managed. It's kind of germane to the information technology services department. So they're managing the email servers, the messaging servers, video conferencing, things of the like. And I would say more on that. Transaction processing. As soon as you see the word transaction, think database. And this will become more clear in 2 weeks. Our chapter on database management systems is lecture module 12, I believe. So we'll look at this in much greater detail in chapter 12. But with transaction processing, what do we have? Order entry systems. So all e-commerce point of sale systems fall into this. Payroll systems, accounting, anything that really uses the database for that transaction premise. I will introduce now what is a transaction, because we need to be very specific on these things. A transaction is an atomic action, meaning it's indivisible. It cannot be divided into its components and should not allow it to be divided into its components. We think about bank transactions, right? And we're very familiar with this. If I want to deposit money physically in a bank, and I go to the bank, walk up to the teller, I hand them $100. They, of course, count it and then increment my balance by $100. That has to be treated as an atomic or indivisible act. It should not be permissible for me to walk into a bank, hand them $100, have the teller count it, and then the system crashes and they never incremented my balance. A transaction must be treated as indivisible, one atomic action. So it's several things actually rolled into, you know, essentially encapsulated into an atomic action. Management information systems and decision support systems. Well, recall what I said yesterday and previously. Databases are at the core of everything we do. Let's take a look. I'm going to introduce something. We've already seen this graphic, okay? We understand that information to be actionable, hopefully, is complete, accurate, timely, and relevant. There's also a temporal component to this graphic. I gave the example yesterday that, for Black Friday, staffing a store for Black Friday. The operational managers can draw from the statistics from the past 20 years. They know what their sales were, and likely we can project that they're going to be continue. So the information is relatively complete, almost complete, accurate, timely, and relevant. So they can make their staffing decisions. I need 7 salespeople on the floor for Black Friday. Recall what I said about tactical decisions. Well, what should we stock in the store? Okay, electronics, what types of clothes, winter coats, is it going to be a cold winter? So that there's a bit of imprecision here, unpredictability. Okay, the information will not be complete. So these middle managers need help in driving their decisions. Some of this information may come from the outside. We're going to see this increasingly as we go up the pyramid. In the case of winter coats, maybe we have information coming in from weather forecasters for how cold or warm a winter it's going to be. And as I said yesterday, executive managers, well, should we even have a brick and mortar store? And again, external threats, unforeseen threats, who knew, the pandemic was coming. But I want you to recognize too, there's a temporal component to this pyramid. Operational managers, when they're staffing for Black Friday, 2 to 3 weeks out, maybe, and I'm just guessing here. And it's going to be different for every industry. Middle managers, should we carry winter coats? And if so, how many? Well, they're probably making their orders in preparation for Black Friday, August, September. So 2 to 3 months out. Again, it depends on the industry. And then the executive managers, should we be in the brick and mortar industry anyway, 2 to 3 years out. So as we go up this pyramid, the information becomes less precise, okay, less complete, but there's also a temporal component on when the decisions are being made and when they're enacted. Okay, so management information systems, essentially, again, hopefully it's an enterprise system that serves everyone within an organization, will support each one of these constituencies. And the workers themselves, by the way, are probably accessing the information in that database and using, of course, that MIS. Decision support systems. Decision support systems assist people, managers, with making decisions when there is imprecise or incomplete information. So they can put all the, possible paths, they can lay them out. Essentially, I introduced this back in application software. They facilitate what if analysis. They're complementary to this. So I can take a look. Well, what if we have a warm winter? In past warm winters, this was my sales for winter coats. Cold winters, this was my sales for winter coats. Well, what's the consequences of keeping these things in inventory and blowing them out at the end of the year at 50% off? I have to evaluate all of these things. Decision support systems will support this type of analysis. Enterprise systems. Again, this is that holistic, hopefully singular view of your information systems. Recall what I said, it's much easier if you have a single database. If I have three databases, likely I need to integrate them, which means I need middleware, which means I need to retain programmers to continually update that middleware. Okay, so you can see how my costs, the true cost of infrastructure, salaries, rises steeply. So with a true enterprise system, it will serve all constituencies throughout that pyramid. Inventory, supply, chain. Again, inventory, we're looking at databases. Supply, databases. Value chain is a little more esoteric, customer service, things like that. Again, if I can manage my supply chain well, think about what this would allow me to do. Again, I use the example of I'm making chips, right? If I can get better resources to where I have fewer chip defects, of course, with these, if I have fewer chip defects, I'm going to have less or fewer defective systems. If I have fewer defective systems, maybe I can decrease my help staff, my IT help desk staff. Recall, my IT help desk is pure overhead. They're not selling new systems. They're supporting the established base of systems that's already out there. If that established base of systems is essentially error prone, I wouldn't even need IT help desk, right? I wouldn't need to pay those salaries. So managing the supply chain has actually become very important in how efficient and effective an organization is. Now, the value chain. Value chain goes in again into more qualitative aspects. Okay. I want to support in both the supply chain and value chain. Hopefully, we can manage it both upstream, where we're getting our materials, and downstream, to where, of course, our customers and clients are. With the value chain, what do our clients see as value? Okay. Or can we provide value back upstream to the chain to our suppliers? Okay. So again, if I can create these and create and manage these relationships, the organization, the system will be much more effective. Intelligent agents. Okay. I actually introduced this term back in operating systems. The textbook talks about users and applications. Okay. Increasingly, though, we have these agents, whether on our phone, in our house, Alexis, things like that, Siri, that are acting and can act on our behalf with our authorization. Okay, recall the responsibility versus authorization presentation. So we're seeing these in many cases on both our desktops, our notebooks, and within our phones. Okay. One of the things to keep an eye on, especially with chatterbots, okay, something has been introduced, a new technology that's actually very accessible. If you're a computer scientist, you should be able to implement this pretty quickly. Chatterbot are using what we call AIML, artificial intelligence markup language. We know what HTML is, right? Hypertext markup language, and XML, extensible markup language. AIML takes it a step further and can incorporate machine learning. This is a way to have intelligent agents from the organizational side responding to customers or clients. Okay, and we're seeing these, and truthfully, they are getting better. We see what's on, you call into Verizon or go on to chat with Verizon or Spectrum, one of these companies. And of course, you're probably interacting with a chatterbot. But they are getting better. I still don't like them, but or interact. I don't like interacting with them, but they are getting better. Moving into, say, expert systems, neural networks, we're moving into artificial intelligence. It is likely that you have interacted with an expert system without knowing it at the pharmacy. Okay. Pharmacies were one of the first to develop and deploy expert systems. Mycin was the first one. And what of course, the medical community understood was it's becoming increasingly complex to understand drug interactions and even understand all the medications that an individual may be taking, because that individual may have, many doctors, many physicians, you know, writing prescriptions for them. So the way to assess this, of course, is at the source where they're getting their prescriptions. So someone walks up to a pharmacy, they hand them the prescription, their information is in there, and that expert system consults its knowledge base, okay, on all the contraindications and interactions of medicines, and through its interference, pardon me, inference engine, which is its programming, it determines if there's a likely contraindication or something ill could occur. So expert systems are formally in the area of artificial intelligence. And again, it's quite likely if you've ever had a prescription filled unknowingly in the back end was an expert system that performed this calculation. Neural networks. Neural networks learn, okay? And what they're particularly good at is pattern recognition. So when we talk about this, image recognition, so facial recognition, body language, optical character recognition, autonomous vehicles for driving, vision systems, all employ neural networks. And neural networks, just like machine learning, which actually are a form of machine learning, will iterate over these patterns to learn and get better and better at their identification. Increasingly, we're seeing them in medical imaging and crime analysis because the computers can see relationships that we might not see. One of the most recent ones was the assessment evaluation of radiological x-rays. And one of the machines, through its neural networks, its machine learning, was able to identify a new relationship with breast cancer that was previously unknown. So it was added to one of those factors that would be used, you're at risk, a predisposition to breast cancer. So this was through the use, of course, of machine learning. Robotics. The AI and robotics revolution is here. And it's taking jobs away. Driverless, autonomous, tractor trailers are coming. Something to keep an eye on if you want to monitor this is General Dynamics, Boston Dynamics out of Boston. Very active in the creation and research of robots. Last year, it was the first construction site robot was released and is being sold to both carry heavy loads, cement, things of this nature, but also do, bolting, riveting, things like that. We're seeing military robots. Boston Dynamics just released a robot for warehouses. Okay. Here in upstate New York, we have several. I look at the big warehousing centers of Target, Ace Hardware, Walmart, Staples. They're around. They're all throughout our community here. Amazon. And they employ a lot of people. And once the robots get here, those people will not have jobs. Business IT society. It's going to affect society. When we talk robotics, we also have to talk just about automation. The checkout counters in our supermarkets now. Fewer and fewer check out with a person. It's now, self-checkout. Many states have gone to kiosks for their DMVs. So no longer do they have a DMV, staffed by people. It's a kiosk in a mall. You walk up, you put your license in or registration, You fill out or provide the necessary information and you get a new license and registration. Well, these people that work at DMVs, they're actually paid very well, many of whom do not have college degrees. Will they ever get a job that pays that well again? You know, these are all these societal questions that we have to assess. We, ACM Code of Ethics, Professional Conduct. We're responsible for assessing all the risks, all the negative consequences, even though they're kind of outside our realm of IT here. That completes chapter 10. If you have any questions, please let me know. Otherwise, that's all I have. So have a great weekend. Thank you.
Thank you.